Hello students, how are you? I hope all of you are good. So in this video, I am going to start the introduction part for the exercise 13.3. Introduction of this exercise 13.3 mainly involve with the two concepts. In that the first one is a theorem of total probability and the second concept is a Bayes theorem. So what is the first concept here? The first concept is theorem of total probability. Theorem of total probability. Theorem of total probability. See here, what this theorem states us. Suppose, let us consider one of the random experiment with the sample space S. Let us consider a random experiment. A random experiment. Random experiment means the experiment in which it has more than one results and we cannot predict its results in advance. So suppose this is a sample space. Yes, this is what? One of the sample space. Yes, which is the largest set in the probability. So this sample space is considered as a universal set. So let us consider a sample space and let E1, let E1, E2, E2 and E3 and En or E4 and so on so En and so on so En are the n mutually exclusive events associated with the sample space S. So what are this E1, E2, E3 and so on so En and E1, E2 and so on so En are n mutually exclusive events associated with the sample space S. Associated with the sample space S. Mutually exclusive events means E1 intersection E2 and so on so intersection En should be equal to null set. There is no common things in between E1, E2 and so on so En. So such type of events are known as what? Mutually exclusive events. Mutually exclusive event means there is no common elements between E1, E2, E3 and so on so En. And here is one of the event. Let A be one of the event. Let A be any event associated with E1, E2, E3 and so on so En. E1, E2, E3 and so on so En. Associated in the sense, here I am going to consider one of the event which is associated with these all the events E1, E2, E3 and so on so En. Associated means A in E1, event A in E2, event A in E3 and so on so event also A in En. But there is no common between A and E1 for E1 and E2, E1 and E3, E2 and E4, anything it may be. A is exist in E1, E2, E3 and so on so En, but there is no common elements between E1, E2, E3, E4. See here, adu henga nodri, let us consider one small example here. Suppose E1 one of the event, E1 is one of the event and E2 is other event. E1 is a event getting a black cards, getting black cards, and E2 is a event getting red color cards. So here E1 and E2 are the mutually exclusive events because E1 is with the cards in black colors and E2 with the cards in red colors. But one of the event A which is in E1 as well as in E2, but there is no common. That is nothing but let A is a event getting a king cards. Getting king cards. Observe here, king cards exist in E1 as well as king cards exist in E2. But in E1, king is in a black color card and in E2, king is in red color. It means A1 intersection E2. E1 intersection E2 is null set. This is nothing but associated to E1 and E2. So similarly here also A is one of the event which exist in E1, E2, E3 and so on, so even En, but there is no common. I hope all of you understood this. And see here we need to identify probability of the event A. We need to identify the total probability of the event A. It is nothing but probability of A, which is equals to probability of A intersection E1 plus probability of A intersection E2 plus probability of A intersection E3 plus probability of A intersection E4 and so on, so probability of A intersection En. Total probability of the event A is probability of A intersection E1 plus probability of A intersection E2 plus and so on, so plus probability of A intersection En. This is what probability of the event A, nothing but total probability of the event A. And here we know that conditional probability concept. Probability of A divided by E1 is equals to probability of A intersection E1 divides probability of E1. By this formula, we may write the probability of A intersection E1 is equals to probability of E1 into probability of A by E1. So here we may write it as what? Probability of event A is equals to, by the cross multiplication, probability of E1 into probability of A by E1 plus, similarly if this is a by E2 formula, probability of A intersection E2 divided by probability of E2. By the cross multiplication, probability of A intersection E2 is equals to probability of E2 into probability of A intersection E2. I hope all of you understanding. Probability of A intersection E2 is equals to probability of E2 into probability of A intersection E2 plus and so on, so probability of En into probability of A by En. So this is what total probability of the event A. I hope all of you understood. So this is what the probability or total theorem of the probability. And the next concept is, so just observe the concept here. So when we are applying in the problems, we are going to understand easily this theorem. See here, or by considering the second concept, we are going to understand this, why we studied this total theorem of the probability. Now what the second concept in introduction part for the exercise 13.3 is most important concept. From this concept you are going to get the 3-mark questions in your annual exam. And the second concept is Bayes theorem. Second concept is what? Bayes theorem. See here, in this Bayes theorem, suppose we have 3 boxes. We have 3 boxes and that 3 are identical boxes, means they have same shape and same size. Suppose the box E1 and E2 and E3. So out of these 3 boxes, let us suppose first box E1 consists 2 red balls and 3 black balls, and second bag consists, or second box consists 4 red balls and 5 black balls, and third box consists 5 red balls and 3 black balls. So out of these 3 boxes, let us suppose one ball is drawn, and that drawn ball is red, and that drawn ball is a red. That red ball is in E1, E2 as well as in E3. So let's define this is a event. And this A event is associated to E1, E2 as well as E3. So what is this A event? A is nothing but getting red ball. Getting red ball. But we don't know that red ball is obtained from the first or second or third box. We just drawn one of the ball at random from any one of the box. We don't know from which box it is drawn. The question he asked here, what is the probability that ball is drawn from either first box or second box or third box? This is what calculated by using the base theorem. See here, suppose there exist three identical boxes and first box consists some number of red and black balls. Second box also consists some number of red and black balls. Third box also consists some number of red and black balls. And one ball is drawn from one of the box, but we don't know which is that box. And that drawn ball is obtained or found to be a red ball. The drawn ball is red ball, but we don't know that ball is drawn from which box. He asked the question, what is the probability that ball is drawn from? Either he may be asked from the first box, second box, or from the third box. If suppose he asked, what is the probability that the red ball drawn from the first box? Then its formula is probability of here ಹೇಳ್ತಾ ಬರೀತೀನಿ ನೋಡ್ರಿ. Then we need to identify the probability of red ball from the first box. Probability of, we know that obtained ball is red and it is defined by the A event. Probability of this red ball from the first box, probability of the red ball in first box is equals to probability of, by the conditional probability formula, probability of E1 by A is equals to probability of A intersection E1 divides probability of A, or it is equal to probability of E1 by A is equals to probability of E1 by A is equals to probability of E1 by A is equals to, as you know that probability of A intersection E1 is equals to probability of E1 into probability of A by E1. Probability of E1 into probability of A by E1 divided by total probability of the event A. So in this theorem of total probability, we have n number of events. That's why probability of A is equals to probability of E1 into probability of A by E1 plus and so on. So probability of En into probability of A divides En. But here we have only three mutually exclusive events. Therefore, probability of A is equals to probability of E1 into probability of A by E1. Probability of E1 into probability of A by E1 plus probability of E2 into probability of A by E2 plus probability of E3 into probability of A by E3. I hope all of you understood this. And suppose if he ask what is the probability of getting red ball from the second box anta kelidnappa andre formula is going to change here. Avag ಏನು ಬರುತ್ತೆ? Probability of, I just feel to you the formula obtained to calculate the probability of red ball in the second box. That is what? Probability of E2 by A, because second box event is E2. Probability of E2 by A is equals to, ಈಗ ಏನಾಗುತ್ತೆ ನೋಡ್ರಿ ಮೇಲ್ಗಡೆ, probability of E2 into probability of A by E2 ಬರೀತು ನೋಡ್ರಿ ಪೂರ divide by total probability of the event A. So same thing here also there exist three events, so therefore same thing we need to copy here. Here also probability of E1 into probability of A by E1 plus probability of E2 into probability of A by E2 plus probability of E3 into probability of A by E3. I hope all of you understood. If we ask probability of getting red ball in the third box, the formula is again changes. Probability of E3 by A is equals to probability of E3 into probability of A by E3 divided by same thing. I hope all of you understood. Depends upon the problem, we are going to change the formulas. So in this questions, you need to write the formula. So you need to understand how to write the formula depends upon the question. See here, if suppose, so here is first example I considered here. E1 is a box which consisting the black cards and E2 is one of the box which consists only red cards. And from these two boxes, he has to select one card and that card is found to be king card, and the card is found to be king card, but we don't know that card is drawn from whether first box or from the second box. But he asked the question, what is the probability of getting this king card from the second box? What is the question here? Probability of getting the king card from the second box. Formula nodri enagutte ಈಗ ಇಲ್ಲಿ ಬರಿತೀನಿ ನೋಡ್ರಿ. So probability of the king card in second box. Probability of, given that drawn card is king, that's why divide by a. From the second box, so probability of E2 by a, which is equals to same thing, probability of E2 into probability of A by E2 divides. Here total number of mutually exclusive events is 2. Therefore total probability of the event A is probability of E1 into probability of A by E1 plus probability of E2 into probability of A by E2. So this is what the formula to identify the probability of king card from the second box. If suppose he asks what is the probability of getting king card in first box, formula ಏನಾಗುತ್ತೆ ಅವಾಗ ಇಲ್ಲಿ E2 ಇರೋದು E1 ಆಗುತ್ತೆ. Probability of E1 by A is equals to probability of E1 into probability of A by E1 divided by same thing. I hope all of you understood. So you are going to get the 3 mark questions from the base theorem concept in your annual examination. I hope all of you understood these 2 concepts. Let's start some of the examples based on base theorems. So solved example and there is no questions on the theorem of total probability, but in exercise 13.3, first question is based on the theorem of total probability. So when we are going to solve the 13.3 exercise, so first problem based on the theorem of total probability, I'll discuss ಮಾಡೋಣ ಆ ಪ್ರಾಬ್ಲಮ್ ಹೆಂಗೆ ಸಾಲ್ವ್ ಮಾಡಬೇಕು. So now the solved examples in your NCERT textbooks is based on the base theorem. So just I solve in this video the problems or questions based on the base theorem. And the first question is, see here is the first question. So this is similar to the question I considered in your explanation in the base theorem concept. See here in this question he has given that, bag 1 contains 3 red balls. Bag 1 contains 3 red and 4 black balls, and another bag 2 contains 5 red and 6 black balls. See here there exist 2 bags. Here there exist 2 bags. Suppose this is a first bag. Suppose this is a first bag or bag 1, and this one is a second bag. This one is a second bag. This one is a second bag. So in this question he has given that the first bag consists of 3 red and 4 black balls. 3 red and 4 black balls. And second bag contains 5 red and 6 black balls. 5 red and 6 black balls. And his question is, see here, one of the ball drawn at random from one of the bags. But he don't know that ball is drawn from the first or second bag. See here, and then he given that it is found to be red. The drawn ball is found to be red. One ball is drawn from one of the 2 bags, and that drawn ball is found to be red ball. So given event here in this question is drawn ball is a red ball. So given event we considered what? A. So what is A event in this question? In this question the A event is drawn ball is red. Drawn ball is red. And his question is, find the probability that it was drawn from the bag 2. His question is what? What is the probability of getting this red ball from the bag 2? I hope all of you understood. Here there exist 2 bags. First bag consists 3 red and 4 black balls, and second bag consists 5 red and 6 black balls. And from these 2 bags he has to choose one of the ball from one of the bag. From one of the bag, and drawn ball found to be a red ball, and we need to identify what is the probability of getting that red ball from the bag. I hope all of you understood. So now here we need to calculate the probability of the red ball from the bag 2, and in this question totally we have 2 bags. It means in this question we have 2 mutually exclusive events. And in that, the first event where E1 is the event. Suppose the ball is drawn from the bag 1. E1 is what? Representing the first bag. And E2 is representing the second bag. E2 is what? Representing the second bag. And we need to calculate probability of this red ball from bag 2. Therefore, required probability is probability of the red ball from the bag 2. That is probability of E2 by A. And its formula is already known. Probability of E2 into probability of A by E2 divided by total probability of the event A, probability of E1 into probability of A by E1 plus probability of E2 into probability of A by E2. I hope all of you understood this. And now let's substitute the respective values. So we need probability of E1. Therefore, probability of E1 is probability of the E1 representing the bag 1 and total number of bags is 2. First bag is representing one event, therefore 1 by 2 is the probability of getting E1 event. And similarly, probability of E2 is also equals to 1 by 2. Total number of bags is 2 and there exists only one bag 2, therefore probability of E2 is 1 by 2. And also we need probability of A by E1 and probability of A by E2. Probability of A by E1. See here, the geometrical meaning of this is probability of the event A given that E1 is appeared. It means probability of the event A means probability of the red ball in E1 means first bag. So probability of red ball in E1 is what? Total number of balls in the first bag E1 is what? 7. And out of 7 we have 3 red balls. So therefore probability of A by E1 is 3 by 7. Similarly, probability of the red ball in bag 2 is equals to total number of balls is 11. Out of 11, 5 red balls. So therefore 5 by 11 is the probability of A by E2. I hope all of you understood this. Now, required probability of E2 by A. E2 by A is equals to probability of E2 is 1 by 2 into probability of A by E2 is 5 by 11 divided by probability of E1 is 1 by 2, probability of A by E1 is 3 by 7 plus probability of E2 is 1 by 2 into probability of A by E2 is 5 by 11. Therefore, probability of E2 by A is equals to probability of E2 by A is equals to 1 into 5, 5 divided by 2 into 11, 22 divided by 1 into 3, 3 divided by 2 into 7, 14 into 1 into 5, 5 divided by 2 into 11 is 22. And then 5 by 22 numerator as it is divided by in denominator we may take the LCM here. So I just calculate directly LCM 14 into 22. So here multiply by 22, here multiply by 14. 3 into 22 is 66 plus 14 into 5 is 70. Hence, the required probability of E2 by A is equals to 5 divided by 22 into ಇದು ಮ್ಯಾಲೆ ಹೋಗಿ ಉಲ್ಟಾ ಆಗುತ್ತಾ 14 into 22 divided by 66 plus 70 is equals to 136. And now here we may cancel 22 22 remaining. Again you may cancel here 2 sevens are 14, 2 6s are 12, remaining 1. 16 means 2 8 is 16. So final required probability or probability of the red ball in the second bag, probability of E2 by A is equals to 5 into 7, 35 divided by 68 is the required answer. I hope all of you understood, and this question is most important for your 3 mark, many times asked in your annual examination. I hope all of you understood this question. Now let's start the next question. And the next question is given 3 identical boxes. So in this question he has given that given 3 identical boxes, identical in the sense same boxes, the boxes which are having same size and same shape. So we have 3 identical boxes 1, 2 and 3, and each containing 2 coins. In that box 1 consisting both are gold coins. See here, suppose this is a first box. Suppose this is a first box, and in this first box the both 2 coins are gold. And suppose this is the second box, and this second box consists both are silver coins. So in second box we have the silver coins, and suppose this is a third box, and in box third there is one gold and one silver coin. So one gold coin and one silver coin. One gold and one silver coins. So this is a given information. We have 3 identical boxes, each box consisting 2 coins, and first box consists both are gold coins, second box consists both are silver coins, and third box consists one gold and one silver coin. And then he has given that a person chooses a box at random. Out of these 3 boxes, first he has to choose one box at random. So he may choose either first, second, or third, and then takes out a coin. He has to take one of the coin from the selected box, and if the coin is of gold, if that selected coin is a gold, if the selected coin is a gold, it means this is a given event in this question. What is a given event? Given event is A, and A event is drawn coin is gold. Drawn coin is gold. Drawn coin is gold. And then his question is, what is the probability that the other coin in the box is also of gold? See here, he asks in indirect way. Out of these 3 identical boxes, first he has to choose one box at random, and from that selected box he has to choose one coin, and that coin is bound to be a gold coin. And his question is, what is the probability that he may ask first box, second box, or third box, but he asked here, what is the probability that the other coin in the box is also of gold? One coin tagdana, it is obtained as a gold coin, or it is found to be a gold coin. But he asked, what is the probability that the other coin in the box, the remaining coin in the box, is also of gold? One gold coin ಹೊರಗಡೆ ಬಂದ ಇನ್ನೊಂದು ಬಾಕ್ಸ್, ಇನ್ನೊಂದು coin ಬಾಕ್ಸ್ ಅಲ್ಲಿ ಇರೋದು ಏನು ಗೋಲ್ಡ್ ಇರಬೇಕು, ಅದು ಯಾವ ಬಾಕ್ಸ್ ಅಲ್ಲಿ ಇರುತ್ತೆ? Box which consisting the both are gold coins, and both are gold coins exist in the first box. Therefore the question is, what is the probability that the drawn coin is gold from the first box is the question. First box ಅನ್ನೋ ಬದಲು ಅವನು ಹೇಳೋಣ ಇಲ್ಲಿ, probability that the other coin in the box is also of gold. So therefore required probability is, therefore required probability is probability of E1 by A, probability of the gold coin in first box, which is equal to, the formula is probability of E1 into probability of A by E1 divide by, here we have 3 boxes and we have 3 mutually exclusive events. Therefore total probability of the event A is probability of E1 into probability of A by E1 plus probability of E2 into probability of A by E2 plus probability of E3 into probability of A by E3. Now we need probability of E1, probability of E2, probability of E3, and probability of A by E1, probability of A by E2, and probability of A by E3. Now first define the event E1. So what is E1? E1 is, suppose the choosing box is first box, that is box 1, and E2 is the event choosing second box, and E3 is the choosing the box third. And here the probability of the event E1, probability of event E1, total number of box is 3, out of 3 1 is box 1, therefore probability of E1 is 1 by 3. Similarly probability of the second box is same thing, 1 by 3, because out of 3 box we have only one second box. And similarly probability of E3 is also equal to 1 by 3. Now we need what? Probability of A by E1. Probability of A by E1 means probability of gold coins in first box. Total number of coins in the box is 2. Out of 2, there exist 2 gold coins. Therefore, 2 by 2 is the probability of A by E1, which is equals to 1. And then probability of A by E2. It means probability of gold coin in the second box. Total number of coins is 2. Out of 2, both are silver coins. It means 0 number of gold coins, which is equals to 0. Probability of A by E2 is 0. And similarly, probability of A by E3 is equals to total number of coins 2. Out of 2, 1 gold coin. Therefore, 1 by 2 is the probability of A by E3. Now substitute these values in respective places. Probability of E1 1 by 3 into probability of A by E1 1 divided by same thing 1 by 3 into 1 plus probability of E2 is 1 by 3 into probability of A by E2 is 0 plus probability of E3 is 1 by 3 into probability of A by E3 is 1 by 2. Therefore, required probability is equals to 1 by 3 into 1 divided by 1 by 3 into 1 plus 1 by 3 into 0 plus 1 by 3 into 1 by 2 is 1 by 6, which is equals to 1 by 3 divided by LCM of 3 and 6 is 6 divided by here multiply by 2, here multiply by 1. So 1 into 2 2 plus 1 into 1 1. Hence the required probability of E1 by A is equals to 1 by 3 into ಇದು ಉಲ್ಟಾ ಆಗಿ 6 by 3. 3 ones are 3 twos are. Therefore 2 by 3 is the required probability. I hope all of you understood this question.